This is a tutorial on how to create a phosphorylated serine on a protein using the software VMD. And what we're going to do is we're going to create a PGN file which you can read about in the tutorials that are available on the University of Illinois website for the VMD and NAMD software. And after doing some searching through the VMD mailing lists, I found a reference to this PNG file that will get a serine phosphorylated for you. So the first thing that it has is using these particular topology files. I'm storing these, so it's calling a topology file, and then this is where the file is located. So I'm storing those in a folder called topology that is where my protein structure file is as well. So if I go to my folder, the structure file that I'm going to use is this csn.pdb, and then I have this folder called topology, and inside of it there is the file top all 27 prot.na.rtf. That's the first one that's listed here, and I just have to tell it that it's in this subdirectory. Then I also am going to be using, as recommended, a file that's in another subdirectory called stream. And so if I scroll up, I have stream, and inside of that I need to store this top par underscore prot underscore na underscore all dot str. So again, top par prot na is right there. So I have both my files where they need to be. What I'm going to do now is just show you a little bit about this PGN file. So you call in these topologies. Then there are some aliases that need to be made because in many PDB files these two particular amino acids might use CD1 and OXT, but they actually need to be referred to as CD and OT1, so there's an alias that happens there. Then we need to create our segment from our structure file. I'm just going to call that P1 for protein 1. It then applies this patch. This is the phosphorylation patch that will give a -2 charge to the structure that's stored in P1, and it will do that on the serine that's located at amino acid 179. It'll then regenerate angle information, and then it's going to do some things before eventually spitting out a new structure file and a PDB file. Okay, so we can close that. This is stored in our supplemental information to the paper, so you can download that if you want it. It's also on the mailing list, and I'll show a link in the video to where you can get that. So I have a VMD open. I'll load the molecule in, although I don't believe it's necessary to do this. So I load CSN. I don't need the structure file underneath it because that's not important for doing this. Then I need to make sure that I'm in the directory where my structure file is. I also need to make sure that the PGN file that I'm going to be using is in the same directory as the structure file. Otherwise I would need to indicate that it's not in the PGN file. Then I can type source, what did I call that file? PSFgen. The nice thing about the TK console is you can begin to type a file name, and when you have enough characters you can use the tab key and it will autofill the rest of the file name for you. Then if I hit enter, it will go through and it again tells me that there are some poorly guessed coordinates. It'll give me some totals, but it'll say everything is complete. I can then look and make sure that I see the files that it created. So in my PGN file, I told it to create this file. Oh, I did some bad naming. But in this case, I called it csn-ps179 and csn-no-ps179 for the two files. And so I see that I have the one with the hyphen here and the one without the hyphen there. VMD will automatically load these, I believe. No, it did not. So what I'm going to do is delete this molecule and load the one we just created. So I'll load the structure file first, and then I will load the PDB. There it is. And just to verify that I got my phosphorylation, what I'm going to do is I'm going to create a representation where I can see it. So there's the protein itself, and then I'm going to get the residue 179, the residue ID, which is 179. Since this particular enzyme starts at residue 6, we need to use res ID instead of residue. So I'll create that. I'm going to change it to CPK. Then I will zoom in. We can see here that there is a phosphate group there. I can even prove to myself that that is a phosphate by changing the mouse to label atoms, and then I can click on that phosphorus. I'm going to change the mouse back to not labeling, it will just rotate, and I can see that serine 179, that is a phosphorus on that amino acid. So I got my mutation to phosphoserine. And since we have PSF and PDB files, you can rename them so that they have the same name if you like. So for example, I could go in here and I could change this one so that it has the hyphen, so that those two file names match. Okay, so the next thing we're going to do is solvate our enzyme. That'll be in the next video, and at that point we're going to be pretty much up to the point where we can start to do some molecular dynamics and molecular mechanics simulations.